Real numbers exercise 1.3. First question. Prove that root 5 is irrational. Proof. Let root 5 is a rational number. So let us take that root 5 is a rational number. Therefore, we can find two integers a comma b. B is not equal to 0 such that root 5 is equal to now a by b. So if it is a rational, it is in the form a by b. Let a and b have a common factor other than 1. Then we can divide them by the common factor and assume that a and b are co-prime. Now a is equal to root 5b. Squaring on both sides, we get a becomes a square, root 5 becomes 5, b becomes b square. Here a square is divisible by 5 and it can be said that a is also divisible by 5. Now let us take a is equal to 5k, where k is an integer. Now we have to square on both sides. On squaring on both sides, we get a becomes a square and 5k becomes 5k whole square. Now I will mark it as equation 1 and this as equation 2. From equation 1 and 2, left hand sides are equal, then right hands also will be equal. That is 5k whole square is equal to 5b square, which is equal to b square is equal to 5k square. This means that b square is divisible by 5, hence b is divisible by 5. This implies that a and b have 5 as a common factor and this is a contradiction to the fact that a and b are co-prime. Hence, root 5 cannot be expressed as p by q or a by b form. It can be said that root 5 is rational. Question number 2. Prove that 3 plus 2 root 5 is irrational. So first let us consider that 3 plus 2 root 5 is a rational. Find two integers a comma b. B is not equal to 0 such that 3 plus 2 root 5 is equal to a by b. This becomes 2 root 5 is equal to a by b minus 3 root 5 is equal to 1 by 2 in bracket a by b minus 3. Since a and b are integers, 1 by 2 a by b minus 3 will also be rational. If a and b are integers, this becomes rational and therefore root 5 is rational. This contradicts the fact that root 5 is irrational. Hence, we can say that hence our assumption is wrong. Our assumption that 3 plus 2 root 5 is rational number is false. Therefore, 3 plus 2 root 5 is irrational. Now question number 3. Prove that the following are irrationals. First one, 1 by root 2. So first let us consider that this is a rational. Let 1 by root 2 is a rational. Therefore, now find integers a comma b is not equal to 0 such that 1 by root 2 is equal to a by b. Now root 2 is equal to b by a. B by a is rational as a and b are integers. Therefore, root 2 is rational, which contradicts to the fact that root 2 is irrational. Hence, our assumption is false or wrong, and 1 by root 2 is irrational. Second one, 7 root 5. So first let us consider that. Let 7 root 5 is irrational. Find two integers a comma b is not equal to 0 such that 7 root 5 is equal to a by b. For some integers a and b. Now root 5 is equal to a by 7b. Here a by 7b is rational as a and b are integers. There root 5 should be rational. This contradicts the fact that root 5 is irrational. Therefore, our assumption that 7 root 5 is rational is false. Hence, we can say that 7 root 5 is irrational. Now, third one, 6 plus root 2. Now, let us consider that. Let 6 plus root 2 be rational. Let us find that two integers a comma b is not equal to 0 such that 6 plus root 2 is equal to a by b. Now root 2 will become a by b minus 6. Since a and b are integers, a by b minus 6 is also becomes a rational. Hence, root 2 should be rational. This contradicts the fact that root 2 is irrational. Therefore, our assumption is false and hence we can write 6 plus root 2 is rational. Now exercise 1.4. First question. Without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion. First question, 13 by 3125. Here 3125, do the prime factorization method. Here you got a 5 times 5. So the denominator is of the form 5 raised to m. Hence, here the decimal expansion of 13 by 3125 is terminating, because either you should get a 2 or 5. So here we have got a 5. So it is a terminating. Second one, 17 by 8. Here denominator is 8, which is equal to 2 into 2 into 2, that is 2 cube. Here denominator is of the form 2 raised to m. Hence the decimal expansion is what? Here it is a terminating, because we have got denominator is in the form of 2 raised to m. Now third one, 64 by 455. Here denominator term 455, you have to do the prime factorization method. There we have got 5 into 7 into 13. Here we have not got in the form of 2 raised to m or 5 raised to n. Since the denominator is not in the form 2 raised to m into 5 raised to n, and it also contains 7 and 13 as its factors. Therefore, its decimal expansion will be non-terminating, repeating. Non-terminating and repeating. Fourth one, 15 divided by 1600. Here for the 1600, find the factors. 200 is a, 250 is a, 225 is a. Now start with 5, 5 is a, 5 1 is a. So these are the prime factors of 1600. 5 times 5, 6 times 2, 2 times 5. So we have got in the form of 2 raised to m and 5 raised to n. Hence, decimal expansion of 15 by 1600 is terminating, because we have got in the form of 2 raised to m and 5 raised to n. Fifth one, 29 by 343. For the denominator term 343, you have to find the prime factors. So we have got 343 is equal to 7 cube. But denominator is not in the form 2 raised to m or 5 raised to n, and it has a 7 as its factor. Hence, the decimal expansion of 29 by 343 is non-terminating, repeating. So it is non-terminating, repeating, not terminating. Sixth one, 23 by 2 cube 5 square. So no need to find prime factors, already they have given. So denominator is in the form 2 raised to m, 5 raised to n. Hence, here decimal expansion of 23 by 2 cube 5 square is terminating. Seventh one, 129 divided by 2 square, 5 to the power 7, 7 to the power 5. So, write down the denominator term. Denominator not in the form 2 raised to m, 5 raised to n, and it also has a 7 as its factor. Hence, the decimal expansion is non-terminating, repeating. Non-terminating, repeating. Eighth one, 6 by 15. Here, you write in the prime factors from 6 as 2 into 3, 15 as 3 into 5. 3 get cancelled, we have got 2 by 5. So here denominator is in the form of 5 raised to m. Hence, decimal expansion of 6 by 15 is terminating. It's a terminating. Now 35 by 50. Now write down 35 as 7 into 5, 50 as 10 into 5. 5 get cancels. Now we have got 7 by 10. Denominator 10 can be written as 2 into 5. Here denominator is in the form of 2 raised to m into 5 raised to n. So hence the decimal expansion of 35 by 50 is what? It is a terminating. Last question. 77 by 210. So 77 can be written as 11 into 7 divided by 30 into 7. 7 get cancelled. We have got 11 by 30. Denominator 30 can be written in the form of 2 into 3 into 5. Here denominator is not in the form 2 raised to m into 5 raised to n. Hence decimal expansion is what? Here it is a non-terminating repeating. Now second question. Write down the decimal expansions of those rational numbers in question number 1 above which have terminating decimal expansion. Terminating are first one, second one, fourth one, sixth one, eighth one, ninth one. So for the terminating decimal expansions only, you have to write down the decimal expansions. So first one, it is 13 by 3125. Second one, 17 by 8. Fourth one, 23 by 3 square 5 square. Sixth one, 15 by 1600. Eighth, 6 by 15. Ninth, 13 by 15. So first one, it's a 13 by 3125. So divide 13 divided by 3125. So point I will take 1 0 added. Again it will not divide. Again you put 0. Likewise you get 2 zeros. Afterwards multiply with 4. It is 12500. So whenever you divide 13,000 divided with 3125, you will get a 0.00416. So it is a terminating decimal expansion. Likewise you have to solve by other problems also. 17 by 8. So you have to divide it. So you have got 2.125 here. Sixth one, 23 divided by 2 cube 5 square, which is equal to 23 by 2 cube is 8, 5 square is 25, which is equal to 23 divided by 200. So divide 23 with 200, put a decimal point and take 0, 200 ones are 300 remaining, again 200 ones are 100 remaining, now 205 are 1000. So remainder is 0. Now you have got a answer as 0.115. Now next question, fourth one, 15 divided by 1600. So divide 15 with 1600. Take decimal point, still the number not divides, then again append zeros. 16 nines are 144, 2 zeros. Remainder you got as a 600. Now 16 threes are 48. Likewise solve the division. 16 sevens are 112, 16 fives are 80. Now remainder you got as a 0. Then answer is now 0.009375. Now next question. It is 8th one, 6 by 15 and 9th one 35 by 50. Now divide 6 with a 15. Now point I will take 60. It is 15 4s are 60. Answer is 0.4. Now divide 35 with 50. You got answer as 0.7 here. Now question number 3. The following real numbers have decimal expansions as given below. In each case, decide whether they are rational or not. If they are rational and of the form P by Q, what can you say about the prime factors of Q? First question, 43.123456789. Since this number has a terminating decimal expansion, it is a rational number of the form P by Q and Q is of the form 2 raised to m into 5 raised to n. That is, the prime factors of Q will be either 2 or 5 or both. Second one, 0.120, 1200, 12000, 1240 and so on. Here the decimal expansion is neither terminating nor recurring. Therefore, the given number is an irrational number because it is neither terminating nor recurring. Now third one, 43.123456789 bar means again these numbers are repeating. Since the decimal expansion is non-terminating and recurring, here decimal expansion is non-terminating and recurring, the given number is a rational number of the form P by Q and Q is not of the form 2 raised to m and 5 raised to n. That is, the prime factors of Q will also have a factor other than 2 or 5. Thank you. Please like the channel and subscribe it.